All right, so I think we're good. Well, thanks again for joining us. This is Patrick McBride. I'm the Chief Marketing Officer at Claroty, and we're again delighted that you decided to spend a little time with us today. Or in some cases, I guess it's morning, and in some cases it's afternoon and evening. As I was looking through both the registration list and now the attendees, we've got quite the international crowd. Which I guess is kind of par for the course. We seem to draw a nice crowd from multiple continents. So wherever you are, welcome. If you're sipping a glass of wine, put your feet up, and if you're sipping a glass of coffee, hopefully you can do the same before you get rolling. What we intend to do today is spend a couple minutes, probably about 30 or 35 minutes, and introduce Claroty, both the company to you and our technology. And we'll take some questions after that, and certainly if you've got follow-ups, don't be shy. In terms of questions, there's actually a question box right in your GoToWebinar controls, so as you go through and you have some questions, go ahead and type those in. I'll wait till the end to get to them, but we'll go through as many, and I'll stay as long as you'd like and answer those. And as we said, certainly you can follow up. You can reach out directly to me. And I will give you my email at the end of this, or you can, the easy button is just to hit up our website, hit the contact us form, and throw your question out there, or if you'd like to get a deeper dive demo or that sort of thing, we'd be happy to take that as well. All right, so without further ado, I know I can speak, for nearly everybody at Claroty. Actually, we're all here on a mission. A lot of us have joined this because we think this is a particularly important space. Certainly it could end up being lucrative and all that stuff, but that's really a secondary concern for us. I mean, we understand. A lot of us have spent either careers in the industrial control space or in the info security space, and we're particularly passionate about making sure that we improve the security of these systems. We also know that we also set out to help improve the operations of those systems. One of the things that we kind of deal with in this environment, a lot of the folks that we end up talking to on a day-by-day basis are on the IT security side of the house, and they're trying to work and collaborate with their colleagues down at the plant level. So one of the considerations we took early was to do a lot of things with the product specifically to make, there's a pony in there for them, is a great American saying. For the plant floor and the engineering team, they get a lot of value out of the product too. So it's, in the past, we've gone through a situation where sometimes, traditional IT security teams showed up in the plant and operations center, and they weren't exactly welcome. Sometimes they were bearing traditional IT tools that didn't work particularly well in those environments, which we'll talk about in a little while. But so we understand that it's we need to make it work really well for the IT security team. We need to have some capabilities that the OT team would appreciate, find a lot of value in, and we really needed to design this thing in a way that we were able to really promote collaboration between those two groups, and that ends up being important. But let me start off, we'll talk beyond our mission. I want to talk a little bit about the company, introduce that, and then we'll jump into some of the technology and some of the things that we think make, some of the things we needed to do to hit that mission. Just quickly, the name is really the play on words from Claroty to Claroty. The industrial control networks tend to be called these days OT. I guess we get IIoT as well. I'm actually here in Houston today at a industrial control conference with a bunch of folks. Actually across a lot of verticals. Interestingly enough, you always find a whole lot of folks in energy, oil and gas and stuff like that, and pipelines and those upstream, downstream, midstream folks here in Houston. But it's actually a more diverse audience than that, and so there's a lot of talk about IIoT and what the marketing guys came up to create that, et cetera. But whatever you call it, our play on words is from Claroty to Claroty. So let's kind of start with a little bit, some of you are very new to the company, and we'll want to give you a little bit of heritage here. So maybe the first time you heard about us was back last year around September when we publicly announced the company. It was a fun announcement. It was, it makes us, by far the best funded, quote unquote startup in this space. We've got, between our A and B rounds of funding, we've got not only a lot of money into this, into the company. Frankly, I've been at enough security companies to know that it's not just the money. I've seen management teams spend that wisely. I've seen management teams spend that poorly. The team here, I can assure you, will spend that wisely. It's also as important of who's backing you and who's behind you and who can help you do the right things in the market. So we've got some of the most preeminent investors on the planet in our camp. So Bessemer Ventures has a long track record of investing in information security. Team8 launched us it's a cybersecurity foundry in Israel, one of the most prominent startup organizations, and so very happy to be working with them. Innovation Endeavors, Eric Schmidt and his team. But more importantly, that we've got industrial, companies, some little guys like Temasek and Mitsui, so to speak, that are involved, and then some other, guys that really understand security as well, with Marker and ICV. Both understand security and industrial systems. So we're delighted to have a really great roster of investors. So it's very important to a company in terms of its growth and progress, not only to have the appropriate capitalization, but to have people that can really help you and help guide the company along its journey. Back in September, we also announced the Claroty platform. So kind of where we stand here is this, and one of the quick questions we always get is like, well, wait a minute, if you started the company back in July of 2014, what the heck took you so long? Why'd you wait all the way till September of last year to announce it? And the simple answer is because we could. We thought it was particularly important in this environment, in particular, that you took your time. You built a really good product. You got it out. You took the time to really pull the requirements together. You got it out and in front of people in the space. You got them to take a look at it early. We did not want to come out of stealth mode with a beta product, and we don't. We came out of stealth mode, even when we announced we had multiple customers and multiple seven-figure deals already in place. Because we could, is when you have investors like we have, they can put you in touch with people and introduce you into places and make sure that that you get the exposure that you need, while still being very thoughtful about the design and development of the product. So we wanted to exit stealth mode with a product that was, again, not an alpha, not a beta, but a fully baked system. And we're proud to announce that we did just that and have continued on a fairly torrid growth path since then. Our headquarters today is in Tel Aviv, Israel. Stay tuned on that front. Our U.S. headquarters is in New York City. We talked about the investment. We're over 50 people strong now, and we've, as we said, we've got multiple paid production, customers. In fact, I think we're in 8 verticals on 6, implemented in 6 different continents, in terms of the places where our technology is actually implemented. We've been focused on oil and gas, the electrics, chemical, data center, building management systems, and pharmaceuticals. Our roster actually of customers actually goes beyond that. We've got food and beverage customers, for example. We've got folks in the mining industry involved, and several others. So we've done quite a bit with a fairly short period of time, and some wonderful backing. So when I said earlier that I was quite sure that this management team wouldn't just throw money away. I mean, sometimes getting a lot of money isn't, I've seen it happen. It's not always a good thing to some companies. But we've got a very, very experienced management team. Our CEO, Amir Zilberstein, was a co-founder of Waterfall Technologies, served in the 8200 unit in the Israeli Defense Force, some elite units there. With Waterfall, it was one of the first or the original OT, specifically purpose-built for OT network. It's a company that does, it's kind of an advanced firewall. It's, does really physics-based network segmentation. Some pretty cool technology they built. So Amir's got a long track record, not just in understanding industrial systems, but understanding software, particularly in this space. Benny Porat, who is our Chief Technology Officer, also came out of the IDF 8200 unit. He led some of the elite units there. Galina Antova came from a career at IBM and then Siemens, so has deep heritage in the industrial space. She ran the global security practice there at Siemens. So folks who really understand the space. We're led by, we've got our Nadav Zafir. One of the, I've actually got to update the slide myself. We've also got a management team who's kind of been there, done that, both in cybersecurity and specifically in OT cybersecurity, and really have, because of some of the heritage of our management team, we've got very, very good access to some of the elite research people in this environment. We're not naming names there, of course. They're shrouded in silence here, but we've got a fantastic research team, not just a software engineering team, but a companion research team that is really helping us advance the product. So I'm going to switch gears. We'll talk a little bit about the rising threat in this environment, and frankly, this is a piece of the presentation that many of you on the phone could get. So we're all familiar with kind of the standard industrial security threats, whether it's the attack on the Ukrainian power grid, the German factory, et cetera. We've all talked and spoke about that. But I think some of what's really interesting in the threat environment more recently is some other things that are happening. So outside of the standard industrial control threats, I was a couple weeks ago back at the RSA conference in San Francisco, and just before that, RSA put out some alerts and reports about cyber criminals. For example, targeting and looking to target industrial systems with ransomware. Makes a lot of sense. If I can get a couple $100 out of grandma so she can get her pictures back, maybe I can get more money out of somebody to turn their plant back on if I can actually turn it off. So that's a change in the threat environment that we're continuing to watch and monitor. Other things happening in the background. There's a lot of tools that have been exposed. I mean, we all know if you look at traditional IT security, there are a lot of tools out there, and in fact, you don't have to have a lot of expertise. You can rent the infrastructure to launch campaigns. You can rent the tools. You can actually pay people to launch the campaigns for you, et cetera. So if you take that kind of a threat scenario and play it out in the industrial control space, we're seeing basically it's lowering the bar to what it takes to get into the environment. To be able to actually launch a credible attack in these environments. The bar has really been lowered, but because somebody like one of the terrorist organizations doesn't necessarily have to have the expertise that a nation state might have, they can go buy it or rent it or buy the tools to do that. So that has not taken place. So we want to be a little clear about that, but we certainly there's a lot of reporting in terms of interest from some of those threat actors looking at this. So it's we're all dealing, whether we're in IT security or looking at industrial security. The changing threat landscape is a constant in our environment. It's whatever it is today, it's going to change tomorrow. And so we're continuing to watch that. But I think there's some really interesting, worth watching new threats to our environment that we all have to keep tabs on. So let's switch gears a little bit here and talk about, because we're going to set up some of what we thought about when we were trying to design the system. And let's talk a little bit about some of the industry challenges that we face. So uh, for the systems that are out there, they're kind of inherently insecure. And I'm not, I'm not trying to harp on some of the industrial control vendors. I mean, a lot of the vendors, they've really done a nice job in the last couple of years of, working to up their game, building security, into the systems that they're providing. But let's face it, a lot of the plants and infrastructure that's out there that's being controlled by industrial systems is 10, 15, 20, 25, even 30 years old. The design goals there were never, cybersecurity. It was, there was just a different set of design goals. It was safety, availability, resiliency. Those were the primary design goals in those systems, not cyber. So the result of that is many of those networks, have a flat network architecture, very little segmentation. They've got weak or non-existent authentication into, like, for example, management workstations, no encryption, of the protocols running around those networks, et cetera, and rare patching, and that's one part. For a long time, the vendors frankly weren't keeping their eye on the ball in terms of what the vulnerabilities to the systems were. But even if they did and were able to create the patch, we all know that if the choice is I can apply a patch, but I have to take the process down for some period of time, that's going to happen not on the same schedule that we are used to in IT environment. And in some cases, we've got a client that does oil exploration. They've got ships that are vessels that are out to sea for 5 years on a time. They may apply an emergency patch if they really, 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 really have to. Stop drilling or for a little while and apply it, but that's almost never happens. And really, any other patches they're going to apply once those boats come in every 5 years. So I mean, that's the schedule. That's what we're dealing with here. So it's not that industrial folks are just asleep at the wheel. It's many cases we know these systems can't be patched. So that's one set of concerns. We all know that these systems, we've been talking about convergence for a long time, and there's just, seemingly overwhelming business value in converging these systems, whether it's for the simple use case of, the vendor remote access rather than having to, drive and fly out to sites to do changes to the environment. Vendors, the industrial vendors and or other integrators that are making making the changes to these environments, keep maintaining them. The contracts, they can VPN in, so that's kind of the easy use case. But, there's a set of more executive level use cases, the shop floor to top floor visibility. What are the KPIs, plant A versus plant B, how's that going? We're seeing a lot of analytics projects drive this, getting a lot of data out of the industrial systems over into the IT shop so that we can do analytics, whether that's predictive analytics for potential failures of equipment so that we can predict that and run the plan in a way that will minimize that, or whether that's just in analytics designed to optimize the process, reduce waste or maybe change the temperature at which you're cooking chemicals, and all these things that can have bottom line revenue impact or P&L impacting kinds of implications. So there's just kind of an overwhelming push to this convergence. And what we know from that is that opens up potential new attack vectors. It's new ways that if not done the right way and not properly segmented in these networks, and there's not the appropriate boundaries and DMZs in between the IT and OT infrastructure, then that opens up new pathways for vendors to get or attackers to get a foothold on the network. There's historically been a real lack of collaboration. I was actually delighted here at this conference and actually at the ARC conference talking to folks there. I think we've seen some cracks in that wall. I mean, and I mean that in a good way. It's I was at the ARC conference this past year and had a chance in Orlando and had a chance to talk to a bunch of folks there and a bunch of folks at this conference, and we're certainly talking with customers. And we're seeing a new sense of we're in this together. Let's kind of fix it now. There's also some bad stories where we're not in this together, and the OT guys, the plant floor engineering teams really don't want to see the IT team show up, or the IT security teams up. They've heard that corporate's here to help one too many times, and so there's that is not a done deal, and I think this is an evolving thing that's going to take in some organizations many years to fix. But there seems to be because cyber has become really a board level top 5 risk factor for the overall company, it's getting some more focus, and I think that's driving some of the collaboration. But listen, we in some cases, let's take some blame on the IT security side. Heck, even on the vendor side, I spent a good chunk of my career in outside of being On the customer side, I've spent a fair chunk in my career in the cybersecurity space, even on the vendor side, and I watched for years that IT security, traditional IT security companies would promote tools. They learned how to spell SCADA and would promote tools for this environment that really, in some cases, did more harm than good. So, we've taken our licks in the past. Some of those were self-inflicted wounds, but I think we're in a new regime now, both in terms of the willingness, because of it's being driven from top, to work together, as well as the you're seeing tools like Claroty and others being purpose-built for this environment, taking into consideration really some of the specifics of those networks and designing them in such a way that it makes it safe for those networks. I jumped ahead here. In a couple of other things to point out. I mean, just in terms of overall concerns, the big issue was for most IT shops is they don't, IT security teams who are becoming more responsible for the security of these networks. We've definitely seen that as a clear and present trend. In many cases, chief information security officers and their teams are now being, told to make sure that they're, thinking of the whole enterprise, not just the IT side of the enterprise. So, understand what's going on in the industrial networks. And the problem is they have almost no visibility into those networks. So, they certainly, very few of them, if any of them, have any kind of real-time monitoring for those environments. In some cases, they put some level of layered defenses in place. In some cases, that's where those projects are just starting now. But so they're pretty insecure in many cases. They're different. They have safety systems in there. There are stop gaps in some place. But obviously, if you can attack both the core industrial systems and the safety systems, then we can make bad stuff happen. But I think one of the core issues is really this visibility into those networks. I mean, the IT teams have lots of tools. Some would argue too many tools to provide them visibility into all aspects of the networks and the endpoints on the IT side, and are looking for the same level of visibility on the OT side. I would also say that they're looking for the same level of visibility without the same level of inundation of false positives or just too many alerts. So we'll talk about that in a bit as well. So really our design point, if you will, at a very top level, was to solve that problem, provide extreme visibility into those environments, as we like to say, but also to provide some capability for the cybersecurity team at the top, some capability for the plant and operational teams, and then really enable the IT and OT collaboration. If the security team at the level 1 security operations center gets an alert, let me link together a bunch of assumptions that they can understand the alert, they know what's going on, or have some idea of what's going on. At some point, they're going to have to call somebody on the plant floor and do something to collaborate with them. So if you can give these guys a common operational picture, if you can give them a common language to start that discussion with, you can really enhance that discussion, frankly enhance the credibility of the security team in talking with the plant floor, but more importantly, reduce the mean time to resolution. It's not a case where the engineering teams that own that infrastructure are just going to let the IT security teams or the IT teams in general make changes to those environments. That's going to be a collaboration. So that has to be a design criteria in the way these tools are built. It has to be built into it. So that's the setup. Let me talk about what we do. At a top level, the Claroty platform is a real-time monitoring and detection system. We work across all the OT layers, so we're not really concerned with trying to monitor the traditional IT networks at all. That's not our province. It's not something we do. We're providing, specifically visibility, from layer 0 to layer 3, or however you draw your Purdue model of things. So down from the field-connected devices that are connected often with, serial, Modbus, Profibus, et cetera, all the way up through the manufacturing operations. We sit on a span port, as you can see in this diagram. We're a software product, just to make that clear. We can run on a virtualized appliance. We can run on a standalone server in the environment. It depends on what's there, what kind of what kind of rack space you have in your environment, what kind of VM, extra VM, space you have, et cetera. So we can work in lots of different ways. It's a standard, Linux install, so we're friendly to a lot of different kinds of configurations. We basically sit on a span port. We watch, we grab the PCAP, if you will, that comes off of that span port, all that network traffic running around your OT network. and identify all the assets in that environment. That's kind of step one. Step two is identifying who's communicating with who at a very, very granular level. So we, not just IP address A is talking with IP address B. It's, this engineering workstation talks 3 times a day to this, or 10 times or 500 times a day to this particular PLC, et cetera. So we deeply characterize all the communications going on in that network. So inventory is both very useful for the OT team. There's a lot of folks whose inventory is the spreadsheet that they did 6 months, 2 years, 5 years ago, that is a partial inventory because you couldn't get all the serial numbers because they were on the back side of something plugged into a chassis. But so incomplete, certainly. So the OT teams get a lot of value out of that. But for us, really, inventory, it has a value there, but it's a means to an end. It allows us to establish the assets on the network so that we can characterize the assets of communication between these assets and build a really high fidelity model of what's going on in that network. We call it a baseline, and that baseline is really all the legitimate traffic and activity go on. So step one is we go into a training mode. That's usually 3, 4, 5 weeks, depending on the kind of plant and the operations. How often, what we try to do is get through at least one cycle in the plant. Obviously, there'll be new things happening. Some people shut down on a yearly basis, on a quarterly basis, et cetera. So we try to plan it in a way that we can, see the kinds of things that happen when that traffic is happening as well. If not, we've got ways to handle that, not a problem. But we characterize the traffic, we build a high fidelity model, and then we go into monitoring mode, into production. And we can monitor a couple of different things. First of all is anomalies on the network, things that shouldn't happen. We can also monitor really high risk kinds of changes. So legitimate changes, but that may be high risk, so that somebody's making a legit change from an engineering workstation, for example, to a PLC, changing in configuration, maybe doing a config download, maybe doing a firmware update or whatever. But we'll flag those, and if that's the change that Bill makes every Tuesday morning, then we can suppress the monitoring team from seeing that alert, but save it just in case later on we may investigate. That could be a legitimate change from inside the network, but that also could be an insider doing something that may not be legitimate. So we track all that stuff, and we've got ironed out some really nice ways for actual legitimate changes that we know about, we can suppress that so we don't overwhelm the people. So anomalies on the network and high-risk changes are the two main things. Now, switching to anomalies on the network, one of the things that we think is particularly important is we can spot stuff at really all steps in what's called the cyber kill chain. So the IT security folks on the phone are I'm sure, familiar with this, but the cyber kill chain is one that established what are all the steps that an attacker or an adversary has to take to get into a network and do damage or steal information, depending on what their motivation is. And the realization that comes out of this, some of these attacks happen over weeks, some of them over months, and a longer period of time, but they all follow a similar pattern. You have to gain a foothold on the network, whether that's a spear phishing campaign, whether that's somebody plugging an infected laptop into the network, or walking with an infected USB key. From there, the next step ends up being enumerating the network, figuring out what the assets are on there from the attacker's perspective, trying to characterize where they can go, where the weak points are, so that they can get to their whatever their goal is, they can achieve their goal. And so it goes through the steps. So we think it's particularly important to be able to spot those anomalies early in the attack, in the kill chain. If you can find somebody when they're first launching an attack, or just in the early stages of the attack, maybe enumerating the network and trying to figure out where the devices are, that's a whole lot better than being able to tell you at the end that, oh, by the way, they're making this change, this potentially destructive change to the PLC. By the way, you got to be able to do that too, and that's that's super important. But to the extent that you can find things earlier, that's the better. So anyway, hopefully that gives everybody a flavor of what we do. When I said there's a pony in there, for both the security teams and the OT teams, I hope that gives some visibility into that. Again, these kind of alerts that may be legitimate behavior from somebody, But it's stuff that the plant floor guys want to know about. That's certainly a capability that most of the plant floor guys that we talk to are very interested in, particularly monitoring even the vendors, doing things in their network. They like to know what's going on then, even if somebody's VPNing in, and making a change. They'd like to see what that is. And for the security team, being able to spot these attacks as they progress. So I'm going to take a breath there, go to a couple of things, and I'll come back and wrap some of that up. Getting into some of the details, I think that some of the things that make us, set us apart from other folks, we've already, even in the time that we've, been around, had the broadest coverage of vendor support. We've analyzed both the proprietary and the open and the proprietary components of all these protocols. If you're going to do deep packet inspection, if that's your model in getting this information, you better be able to you better have some really good people on your team and a research group that can analyze this. This, by the way, is an incomplete list. There's many more vendors on here, so call this a sample list. Certainly, what matters. I right off the bat, I can think of a couple that are an NOV for the folks that operate vessels, for example. That they're National Oil Barco as just one example that I spot here. But so broad coverage across the vendors, broad coverage across the kinds of network topologies that we see, and really deep coverage, into the protocols. This gives you some idea of kind of things that we can discover. When I talked about the asset, again, asset discovery for us is a means to an end, but it's a pretty useful means for a lot of folks. It's IP addresses and MAC addresses, and what kind of what kind of equipment it is, what protocols we're talking, what the asset serial numbers are, firmware versions, etc. So we can see into PLCs, for example, that may be a rack mount, kinds of things. They've got rack slots and maybe have multiple things, in the PLC, including network cards that might, expose a whole other segment to the network. We can see all of that stuff, and at the bottom you can see the kinds of things that we can monitor, all the different kinds of communications. As an example, again, don't call this a complete list. If there's something on here that's missing that would be important to your environment, ask us before you assume that this is a complete list, please. So what do we do with that? Really with that capability, it enables us to, or you to see into your entire OT environment. There are no customers come up to us and said, can we see just a portion of our industrial network? Everybody wants to be able to see the whole network. They've already seen a portion of their environment. They've typically monitored the IT environment. Now they want to monitor the OT. They don't want to just monitor a little piece of it, not just the IP base traffic. They want to do the serial connections. For example, not just vendor X. They want to be able to see equipment and from vendor Y. That's one piece. They all would like to, a lot of our enterprise customers have multiple plants, multiple sites, so they'd like to be able to roll that up into an enterprise view. So we've got that as well. So the individual plant teams can see their environment, specifically, but that rolls up into an interface that is kind of global for organizations. I mentioned our oil exploration client. They've got ships, multiple ones in the Gulf of Mexico, ships in the North Shore or the North Sea, for example, ships in Singapore and other places. So they want to be able to get a comprehensive picture of that. The next piece is know what's going on, deep insights into your environment. And interestingly enough, when we, one of the first things before we're even doing anomaly detection and that sort of thing, a lot of the value that people get out of it is they plug it in, they get to see their network and dive into their network in ways that they just haven't seen before. They spot all kinds of stuff. They find, misconfigurations of device that, some network device is trying to, is beaconing out to the public internet, for example, or trying to beacon out for the, to the public internet, or, some device that you thought was communicating only within a particular network segment or zone is actually communicating over that zone. You see ghost assets in the environment, something that's talking to something that actually, trying to talk to something that isn't there anymore, certainly not communicating on the network. So lots of little configuration issues. Some of these are basic network hygiene and may just fix performance problems on the network. Some of these are attack vectors that an adversary could potentially use to get in. And in either way, having those deep insights in that network is important. And then, on the secure side, as we said, it's real-time monitoring, not only for security issues, up and down the kill chain, but for potential process integrity issues, that sort of thing. And we talked about the normal and high risk changes. The hanging thing here is context-rich alerts, which I'm going to talk to in a second, and I hit that now. So if the goal, for most, SOCs and NOCs is to get, a few relevant alerts. And I think that's from a design principle, that's really what we set out to do. So don't give me an event stream that said there's a bunch of anomalies between this workstation and that PLC, as an example. Roll it up into a single consolidated alert and tell me that somebody's trying to make a configuration change on a PLC. Don't tell me that there's a bunch of network anomalies between that stuff. Do your work, Mr. Vendor, and give me the rolled up consolidated alert. By the way, preserve all that event information, know exactly what's going on underneath of it if I have to go and investigate it, and et cetera, but don't send that information off to the SOC team. They won't know what to do with it anyway. They don't make them, don't make them hurt their head by trying to have to reassemble all that stuff. So that's a piece of it, having a tightly developed alert that rolls up a bunch of different anomalous events into the thing that's actually happening, so that the SOC team has pretty much instant situational awareness. But then provide me the rest of the context in that alert so that I can investigate it, whether that's the early stages of the attack, am I seeing an Nmap scan, on the network, and what between what devices or what ones, what is it, what's the IP address range that it's going over, so I can investigate. A lot of traditional IT security operations center guys can investigate that to a lot of, to a depth, that they're familiar with that stuff. If it happens to be later in the cycle, it's something, for example, that is impacting my PLC. I'm making a configuration change, on the PLC. Don't tell me that, something's happening to IP address, 10 dot something dot something dot something, because then if I happen to think that may be one of the ICS assets in the network rather than one of the network assets themselves, and I've got to make a call to the plant guy. They don't know the IP addresses. Tell them that that's PLC X, and by the way, tell them what's being changed. Oh, they're trying to make a change to this set point, or that sort of thing. And now you're having a useful conversation between the security operations center people and the folks on the other end of the phone. It's not only about credibility, it's about mean time to resolution. If you call and tell them it's an IP address, you see a bunch of anomalies, for example, between, this IP address and that IP address, they're going to look at you, or, you'll hear, crickets on the other end of the phone. They're not going to know what to do with that. You call them up and say, this workstation's making a change to this PLC, and for example, this is the line of, this is the set point that they're trying to change, the code block that they're actually trying to change. That's actually meaningful. Now they may know it in the process, or they can go to their Rockwell tool or their Snyder system and drop some of that information in there, and work collaboratively now on what's going on. So that's when we talked about this working collaboratively. It's not just sunshine and rainbows and unicorns. This is practical stuff that really has an impact on being able to reduce the mean time to investigate and resolve a potential issue. So this just gives you kind of the standard components of the system. Let me go through it. So at its base level, we use deep packet inspection to do that, deep inventory and baseline characterization of the environment. We implement a couple of different models. The baseline model is the core of it in terms of what's the known good baseline communications on that network, and that's where we do anomaly detection. But we also have a different model in there that it looks at, we understand what are actual critical and high-risk changes, in an OT environment. We bring a, pretty good level of industrial control and OT environment knowledge to this, and have built some cool models to identify that. And on the malicious activity model, don't tell me that it's, a bunch of anomalies. I mean, the thing that might trip something, you're doing a port scan, and the thing that might trip it is, that's anomalous on the network, but don't just say you see anomalous traffic. Tell me what the hell it is, and that's what the malicious activity model is about. So it's really about providing not finding the thing going on in the network. It's not a signature-based thing. I want to make sure that's really clear. It's about trying to better identify it so when you provide the alert to the first person on the other end, they know exactly what it is. At the top layer, the first module we have is our real-time anomaly detection capability. We're leaning ahead a little bit in here. We've got some stuff that's in production at real customers. It's limited availability, but as I said, these environments are pretty critical, and they require a product that really gets put to its paces in a meaningful way. So we've got in limited availability some capabilities there, and we've got some other things that we haven't quite announced yet, so they're TBA for now. As you can see, hopefully from the picture, is we're not trying to build a one-trick pony here. We're not going to be everything to everybody, just make that clear. But there's a set of, we think, really logically connected capabilities for the OT space, so that you don't wind up with what you have in the IT space. We're trying to build a platform that takes care of a lot of these related capabilities. In the IT space, you've got some platforms, but you also got, a whole lot of vendors. There's, I think, at last count, there's like 1,600 vendors in the, cybersecurity space, and I've got a lot of enterprise customers that have, 20 or 30 different ones in their environment. That's not going to work in the OT environment. You can't, with those environments, just the way they operate and move along. You might need a couple of different products. I'm not saying that you're going to need something for network segmentation. We're not going to try to recreate what, for example, the waterfall guys are doing, but we're going to try to pull together a really concise set of modules that will help our security teams over time. So stay tuned on that for some announcements from us in the future. Benefits, know what your network's doing, discover, potentially problematic issues, and, reduce the time that it takes to detect, rapidly detect these things, but more importantly, reduce the time that it takes to investigate and really quickly respond to these environments collaboratively. That collaborative thing ends up being important. Again, if this is an issue in an industrial network, it's not like the IT guys are rushing in there and patching something, doing something, taking something offline. You have to have a different discussion in this environment. So we've taken a lot of care in building this product in a way that helps that happen. I will leave you with this. We think we're quite sure we've got the best visibility into these networks. So we've got the broadest and deepest coverage. We're leveraging a safe, passive approach in the environment. So design goal number 1 for Claroty was do no harm. Design goal number 2 was see design goal number 1, and then we go on to the rest of them. The other things that we've talked about. Let's make sure that when we're working in these environments, that we don't break anything. We've got real-time monitoring, so that's different from folks that would poll different devices, which ends up being not as safe, but also not real-time. If I'm polling something every day and doing diffs on it, once a day, what happened in between the day? If it's every hour, what happened in between the hour? If I'm polling it every minute, then I'm probably putting more traffic on the network than I'd like to do. So we don't put any traffic on the network. We just watch, on the span port. We've built, we think the best anomaly detection, but companion to that, we can also monitor for, real process integrity issues, things that maybe aren't a security issue, but something that could hurt the processing. Certainly that the plant level folks are interested. And we talked about the normal and high risk changes. We've spent a lot of time making sure our alerts are consolidated, condensed, actionable, context-rich, so that we can power that collaboration that has to happen. And we've spent a lot of time making this enterprise ready. We didn't talk a lot about that, but everything from the multi-site console, so it's not you have to look at 10 different consoles. We can roll that all up into one, but it's also optimized for real-world networks. This is the good example. I've got to go back probably more than one time today with our oil exploration company. Hell, they put us through our paces. We had to do a lot of stuff to really meet the demands of their network. As you might expect, if you've got an oil rig out in the middle of the ocean, you didn't drag along an IP or a cable with you. You're doing SATCOM. Those networks are not going to be used only for monitoring, a lot of other things, so you have to be bandwidth friendly, first of all, as an example. You have to, SATCOM networks notoriously go up and down in storms, so you got to be able to, if that network link gets broken, you got to be able to come back up gracefully and make sure you don't drop anything in the meantime. Nobody asks us to monitor stuff, only when the network's up and running. They ask us to monitor it all in real time, and it may be that we have have a delay in getting it back to the security operations center if the network's cut, or the network's down. But give me everything that happened. So the point here is that we've spent a lot of time in real-world network scenarios engineering this and having it implemented in places where they're not always the same kind of huge bandwidth kinds of networks that you run into on the IT side. Powered by the Claroty research team means as we as vendors make changes, as we need to include new protocols and things like that, we're ready to do that. We do that quite quickly. These guys are the best in the business at what they do, and I think we can really keep this product on the leading edge because of them. If you have a great product, you still need a good management team to keep it on the rails. We're in this for the long haul. We've got the investors and the backing to take us where we need to be. Two announcements that I didn't cover that are more recent in the company that I think goes to the kind of the strength of the company. We're very happy a couple weeks ago, just before RSA, to announce that Dave DeWalt, the former chairman of FireEye and Mandiant, has joined our board. He's chairman of our board of directors. He knows what to do in helping grow security companies and address real client needs in a way that makes it not only grows a company for financial benefit, but really understands how to grow a company, grow support, be able to hit all the things that you need to do over time to be a real long-term player in the environment. We also were happy. Rockwell, in fact, announced that they had done a deep investigation of all the technologies out there, some of the startup companies in the space, including us. They chose us. You can see that press release on their site, so a really great validation for our capabilities. So we think we're in it for the long term. We've got the team and the product to go places, and we'd love to continue the discussion with you and take you through a deep dive. I actually went a little over my time. I know I was getting some questions here. Let me bring those up, and I'll answer a couple of that. So one just simple question. It's I've confused some folks with the whole span port idea. So just so I can explain that, how are we safe? What a span port is, most modern switches, not all switches in every environment, most modern switches have something called a mirror or span port. I think span is the trademarked Cisco way of viewing it, if I recall right, and mirror is the more generic term. But what that does is it takes a copy of all the traffic that's traversing over that particular switch and sends it out, out over a specific network segment. It doesn't allow inbound, or it can be configured not to allow any inbound. So in our case, that's the way we do. We're not putting any traffic onto the OT network. We're just looking at it from a copy perspective and taking that that information off of the span and doing that. So that's what it, and that's why it's very safe, in those environments. So we get how exactly can we inspect proprietary ICS protocols? The short answer is we built a multi-million-dollar lab and have bought a lot of that technology, and so we do. We actually have a team that knows exactly how to do that kind of black box stuff. So it's in some instances we've worked very closely with the vendors, but even if that's not the case, we've been able to deeply analyze those protocols. I wouldn't say, hey, I'm the marketing guy, but I'm a Missouri kind of guy too. Don't show me. So if you've got protocols in your environment, we'd love to do a POC with you and show you that that we've done, whether it's proprietary or not proprietary kind of protocols. We know what's going on in those networks. Let's see, a couple other questions here. Top 4 verticals. That's a great question. So, interesting. So, being the one of the things that I had a hand in when I joined the company last year in June was going through an exercise, where we, the verticals that we're focused on, and this had much more to do with us focusing our bandwidth in places, and so in that case it was oil and gas, electric, and chemical, And then we were getting a lot of inbound from folks that were operating data centers, whether it's HVAC systems, building management systems, et cetera, that want us to take a look at that. So we've added that. Having said that, there's a couple things that kind of surprised us. So there's the ones that we focused in and the ones that we've actually implemented in. So I would add to that list manufacturing, both process manufacturing. So we've got a fair number of things there, and actually a nice footprint in food and beverage, which was kind of surprising to us, in terms of the inbound. The other surprise to us was mining. We've actually got quite a few mining concerns that are at various stages. We've got a couple that are already implemented production, large deal customers, but we've got a lot of others in the hopper as well. So I think that probably goes past your 4, but that I think gives you a pretty good overlay of the places where we've been focused on, have customers, and the places where we've had customers even though we weren't focused outbound on hitting that. All right, so I got a pricing question. That's always good. So what's our pricing model? So the cost of the system is a factor of the number of sites, and then within the sites, the number of assets. We've had some, and that's usually a number we can get pretty close to with customers. In some cases, I'll share with you, in fact, one of our large customers, I won't mention even what vertical it's in, had an issue figuring out exactly how many sites they had or how many assets they had within them. So we've got a model for doing enterprise pricing as well, and certainly that's something we'd love to discuss further with you based on your unique scenario. I got time. They try to keep this on track. Looks like I've got time for another couple of another question or two, if we have any. If my cursor would help me out. Okay. I do have. No, I answered that. Well, it looks like we've hit. Oh, we got one more here. Okay. How do I determine firmware version? That's actually a great question. So a lot of folks would think you actually have to pull the device to get that. You'd be stunned at actually how much information floats around in those protocols. As those devices communicate on the network, that's some of the stuff that actually gets communicated. So we literally pull that out of the packets in some of the protocol. Now it doesn't always have a tag within those packets that says this is the firmware version, but we can pick that out. Now there's some very old protocols. I just 100% visibility into us. It's, in some cases, there are some places where you can't get that with some of the older protocols, but in many cases we can. That's useful. There's a whole set of things that people look into in terms of vulnerabilities with different systems, but also serial numbers. Interestingly enough, we can get those out. As talking to people down at the plant, some of the serial numbers are actually hard to pull off these devices too, because they may be in a rack and slot kind of configuration, and the serial numbers on the back side, and the only way to get it is shut it down, unrack it, look at it, and then put it back in. That's changed over time. I think people are getting smarter about where they put some of those things. The vendors are getting smarter about what they put over that. But that's other interesting information as well. But we're pulling that. The short answer is we're pulling that out of the packets. Well, it looks like we've hit all the questions here. Again, really delighted to have you on. We'd be happy, depending on where you are in your journey and looking into this technology and looking at these kind of capabilities. We'd love to have a deeper discussion with you. We'd love to take you through a demo of the product. We can do that online. Set you up with one of our systems engineers so that we can give you a tour. We'll end up doing some webinars over the next coming months where we do some online demos, but we can also do one for you and then answer all your specific questions. So whether you want to join one of our future webinars and see an online demo, or you want to get a personalized one where your team can pepper us with all the questions that you have, we'd love to do that either way. So hit the website, and our contact us is the easy button. You can get to me. I am patrick.m@claroty.com, and the correct or incorrect, if you, depending way you look at Claroty, CLAROTY.com. So be happy to get a direct inquiry from you as well, and I can pass that along to the right folks on our team. So with that, I'm going to wrap this up. Thank you so much for joining us, taking valuable time out of your day. We'd love to hear from you and love to follow up with you. And so have a great rest of your day and great rest of the week, and we hope to talk to you soon. Take care. Bye now.